Okay, final part in this series. This is charged particles. So a little recap. Thinking about electric fields, what will happen if I send a beam of electrons between two electric plates? Well, if you think about it, I'm going to have an electric field, and electric fields always go from positive to negative, and the field shows the direction that a positive particle will take. Now, I don't have a positive particle here, I have a negative particle. So what will happen is my electron will experience a force acting upwards, and it will come up and crash into this top plate. So we're thinking about this idea of free particles travelling through space. Now, here's what we can do. I've got an electron, and it's travelling through a magnetic field. So you should remember from our previous couple of lessons, these crosses mean that the magnetic field is coming out of your screen towards you. And I have an electron that initially is moving from left to right. Now, what does that mean? Well, I can actually use Fleming's left-hand rule here, because I want to know what is the force on my charged particle. So thinking about Fleming's left-hand rule, what direction is the current travelling in? So you have to remember, current is always positive to negative, so it's the opposite direction to the electrons. So current is going from right to left. So what I can do, Fleming's left-hand rule, first finger is coming out of the page, second finger, the current, is travelling out that way, and so what I find is that... Oh yeah, sorry, so did I say it was going into page? Suddenly really panicked myself. So first finger is going to be pointing down into the screen. Sorry, the crosses means going into the screen. The second finger current goes that way. So the force is going to be acting downwards. So direction of the force on the particle is down. Whenever we've done something like this, so what's going to happen is my electron will accelerate and move to there. So here's my electron. Now my electron is travelling that way. What direction will the force be in now? Well, if you think, the first finger field is still going into the page, but now our current has rotated around, so now the current's going kind of that way, so now the force is here. And here's the key thing, it doesn't matter what direction my electron's travelling in, the force is always at 90 degrees. Where have we seen that? We've seen that with circular motion. So something moves in a circle when a force is perpendicular to the direction of motion of an object. And that makes it go in a circle. So, what's going to affect the radius of that circle? So what will happen in reality is if I have an electron in a magnetic field, the electron is going to travel around in a circle like this. And what will affect that speed? Well, if my electron goes faster, then it will bend less, so the radius will get bigger. So if I want my radius to get smaller, then slowing down my electron will do that. If I have more charge, then there'll be more force, so it will turn more quickly. And if I make my magnetic field stronger, it'll do that. What about if I have a load of protons that I blast in that way? What will happen to them? Well, they have the opposite charge, so they'll bend round that way instead. So sometimes you get a question like this. Here is a radioactive source, and we'll do this a bit more next lesson, in the next topic, sorry. Here's a radioactive source, and it is sending out positive particles, negative particles, and neutral particles, all streaming out like that. And what I do is I put it into a magnetic field. And they often ask you, well, what will happen to those particles? I'm just going to change the colours to make it really simple. So I'm going to say my positive particle is blue, we'll leave my negative particle as purple, and I'll make my neutral particle orange. So my positive particle, as we said earlier, that's going to curve upwards. So I'll see my positive particles do this. My negative particles will curve downwards, so I'll see them do this. And my neutral particles, they don't have a charge, so they're not like a current moving at all. What colour did I say for that? Orange. So they will just go straight through. Now we'll cover that a little bit more when we do radiation, but that's just something to be aware of. this is the application of it. In an electron deflection tube, what I have is a vacuum. It's very important to have a vacuum because electrons can't travel through a vacuum otherwise. They just crash into an air molecule and stop. But what I can do is I can bring a magnet near to this. And if I bring a magnet near to it, you'll see the beam will start to bend in different directions depending on which way around you put the magnet.